En este momento en Iztapalapa hay 13.
Okay, let's start. Okay, let's start. Today I'm going to continue with the examples that we were talking about yesterday. I remember that it was about the conditions, logical validators. Just give me a second. I don't remember exactly name, but well, welcome aboard. Welcome everybody. Let's continue today. I'm everything. Remember that all the code that I'm doing is public on GitHub, so you are able to just open the repo and get the latest version. So I'm going to share it on the chat. And now, yesterday we were talking about unary operators, binary operators, less conditional logical operators. Just a final comment about the logical operators is that only we have conditional logical operators. For conditional logical operators, only we have the and or. Conditional logical operators doesn't handle the exclusive or. And now we have the bitwise and binary shift operators and another ones with that we could name miscellaneous operators. For the bitwise, we have. I'm going to comment this other line. Yep. So if you may uncomment this and then shift operators. This is more complex for this. The bitwise operators affect the bits in a number, and binary shift operators can perform some common arithmetic calculations much faster than traditional operators. The bitwise and binary shift operators are at the level of bit. You have to remember that each representation on any application a binary has a binary representation. I mean, we have number 01 variable and it equals to this, right? So number 01, if we have an integer in C sharp, you are able to let's see, you are able to find just give me a second. Okay, yeah. You are able to, if you write up C sharp variable types int type size. Yeah. Integral numeric types, C# reference. You may find this. You have this information, and for example, there you have that an integer is a signed 32-bit integer, and that means that it may has a value around less 2000 millions to up to 2000 millions. From less pass around 0 and then 2000 millions. This What does this mean? This is a 32-bit integer, so it means that you have 32 positions: 1 2 3 4 5 6 7 8 10 20 30 and other 2. I'm going to remove this and this. Oh, I think that it's backwards by 4. 1 2 3 4 1 2 3 4 1 2 3 4. Yeah, that's what we got. So each one of these bits, it's the representation. Remember that the last remember that you write the number and the less value, it's up to the right, and the bigger value is on the left. So I mean that number 01 equals 1. It's the same as if we write 0, 0, 0, 0, 0, 0, 1, because we have this the less significant value to the right, and this is the way how we write usually the numbers on a computational system. If we write less 1 means, and using a sign type means that the first bit or the last bit, this is hard to me to the more the bit that has more value, that will be this one. It's not a 0, it's a 1. This is the one that let us know about the amount, about if the amount is positive or a negative value. You are able to use the calculator, and on the calculator there is a programmer type of calculator. So when you write 2000 millions or 2 billions, yep, you have a representation. Copy. You have a representation like this: number 01 2000 millions, 2000 millions. No, 2000 million or 2 millions, 2000 millions. Okay, this is the same, and the computer has the following value. Mhm. I'm separating this way because we have these numbers and the last one is the sign. So for this case, you have this. If you have less 2 millions, the binary representation of this is this one. Now, talking about the shift operators and the bitwise operators. For the bitwise, you have some values, and you are able, if you use the logical operators that we use in the previous session, we have the and, or, and XOR. So those operators I told you that apply to Boolean values. Number one, int number two. Now we are going to use two different values. I'm going to use 1, 2, 3, 4, 5. Let's see, 7. Yeah, 7. Okay, yeah. I'm going to use the number 7. Its representation is the following. Remember, it's 1, 3, 7. And for the other one, 8, 9, 10. 10, 12. I think that I'm going to use 12. Yeah, I'm going to use 12. Because the representation of 12, remember, it's 1, 2, 3, 4, then 5, then 6. Cell 12. Oh, let's see. Now, got 12. Sorry. It's this one. It's the representation of that. Don't forget that we have an int value. Now, for this case, the bitwise operators are the and or, and exclusive or operations, but applied at the level of bits. So, what are you talking about to this? I'm going to use console write line. So we have value of number 01, number 01, this, then value of 02, and we have 02. Okay, now what happens? We are going to do some operations. Console write line number 01 ampersand and number 02 equals, what's the value of this? Number 01 ampersand number 02. Okay, now we have the same one but with pipeline, or This is the logical operators. It's not the conditional logical operators. Console write line exclusive or this one. I think that exclusive or is the less that I use in my whole life. I only use it when I'm doing examples. Okay. Now what's going on? Not what's going to, what we are going to have here. Well, for here we have the and or operations for the same sections of bits. I mean, it's going to apply an and the and is going to be this first value and the last value. The last value of this and the last value of this. So 1 and 0, 0, 1 and 0, again 0, 1 and 1 equals 1, and then 0 and 1 is 0. The other ones, I'm not going to mention the other ones because the other ones are 0. So it's most than obvious that the other values are 0. And for the case of OR, we are going to have a bigger number. So for this, we're going, for the first one, for the AND, we are going to have 0, 0, 1, 0. And 0, 0, 1, 0, it's 1, 2, 3, 4. We are going to get the value of 4, 4 that equals 0, 1, 0, 0. The second case, we are going to have 12, 12, 13, 14, 15. We are going to have 15 because that's the number 1, 1, 1, 1. This is because we have 1 or 0 is 1, 1 or 0 is 1, 1 on 1 or 1 is 1, and 0 or 1 is 1. So we have a fulfilled zeros. So this case is 15. And for the case of exclusive OR, we are going to have well, the binary value is this one, 0, no, 1, 0, 1, 1. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So I'm going to save this. Let's go to the terminal. There. Net exercises there. X01 there. 01 there. Yeah, now I'm here. Clear screen, and then .NET build. We have issues, warnings, the variable it's assigned but its value is never used. Yeah, the previous examples was with only bool variables. Going to delete that, well, comment that. Now .NET build. What's the case here? Clear screen, .NET run. Here we have hello world, value of number 1, 0, and as you see, it's value 4, 4, 15, 15, and 11, 11. Okay, now what is this for, or what I wish to use this kind of operations on the program? Uh, the the more useful way that I have for this is for permissions. If you want to create something that handles the access permissions for several users. Sometimes, if you have used Linux has the permissions like execution, writing, reading, and public. Okay, and for this, the permissions are like this: 0000. So you have to assign a special permission per user. Uh, and this is an example by using this bit. So if the user is a public view, it's one here. If he is able to read it, it's one here and maybe zero here. If he is able to write it, is here. If he is able to write it but not read it, this one. And maybe the user is able to execute it, not to write, not to read, just execution, this one. And maybe execute and read, etc. So what we have several systems that has an admin, that has a manager, maybe a super user, what else, maybe a contributor, a reader, and public. Okay. And this, you are able to use them with enums and maybe using flag enums, so that you will have the way to add them. So usually an enum uses a special value and you assign 0, 1, 2, 3, 4, 5, 6, 7. For a flag value, you are able to apply a sum of the values by binary operators. So instead of having one one for the well, zero for the admin, because it always begins on zero, and then the manager will be one, super user will be two, contributor 3, reader 4, and then 5. This is something that it's okay with an enum, but we are not going to be able to use them with flag enums, or using a binary operator. For this case, it's better to use admin is 1, manager is 1, 0, super user is 1, 0, 0, contributor is 1, 0, 0, 0, 4 is 1 and 4 zeros, and public is 1 and 6 zeros, 2, 3, 6. Um, and then now what do we have? Let's see. Just give me a second. Let's see now. We have this. So, and you have the special user. Okay, you have a user. You have a variable, my user, and my user has the value. It's an admin. It's an admin. It's a manager, a super user, not a contributor, not a reader, not a public. Okay, and then var anonymous user, it's going to be only the public user, right? And then for a writer, it's going to be only, it's not going to be an admin, not a manager, not a superior user, yes a contributor, maybe yes a reader, and not public. Okay, so what's going on here? I have these values. Maybe to be more clear about this is 1 2 3 4 5. Okay, 1 2 3 4 5, 1 2 3 4, 1 2 3, 2 1. Okay, so all the numbers are the same. If you have my user, you have anonymous user, and you have writer. Okay, and all of them have a different permission, but the permission you are able just to remove, placing a zero or allowing the user to access that functionality. Now, how? Well, we have these enums or values, and we are going to do something like this. Var user role equals, for this case, 0011. Okay, and then var permission access, it's going to be a manager. I'm not going to place the enum here, but this is the idea about this, and the manager is 000010. Okay, and then what are we going to do? We are going to do the following. We have if permission access ampersand user role bigger than 0, then continue allow the user to access this section. Okay, and how is this possible? Because we are doing here binary um, a binary operation with this. We are doing like a filtering, and so the only the only permission that is important for us is this one. The second position is in 1, and we are interested that the user is able to struct system. Okay, and the user is able to the user is able to perform the to that the user has this permission, this one. And sometimes you have sections where you are adding more and more and more permissions because it's logic. You have a system that uses several types of access and functionalities, and not everybody is able to access anything. But if today the admin is one value and tomorrow you think you have the request that you will have admins and country admins and admins but by state, then you're going to be like, okay, I have an admin, I don't have a state admin, or I don't have a country admin. So what I'm going to do, and what will happen if the same condition for the country and for the states is asked for each one of the other ones, the super user per state or the super user per country? It's hard to add them once that you have defined the permissions. This structure allows you to just create, okay, I have these ones, and then for this case, I'm going to have the country admin, country, okay, you have the public, and then you have a country. It's going to be one and one more zero than this, and then you have the state. And this is 2 1 2. Okay, now what's the situation for here? We have a country. Now we have the condition of the country, the condition for the state, And now we are able to perform a mix of them. So a country admin will be this thing. We're going to copy this. Country admin is this. A state admin equals this. And what will happen? Someone it's going to say, okay, I need that the country admin will have access to the state admin, and that's crazy, right? That's like, okay, how I am going to do? So a country state admin, you're going to have the last one, and you just change this because this is for the state, this is for the country, and the last one is for the admin. So now you are able to mix them. And if you perform if you if you perform something here, for example, permission access and user role, and the way to validate this is going to be different than zero, right? But when you mix several permissions, it's not going to be only different than zero, it's going to have a value. So maybe you are an admin, and if you apply an AND operation to a country state admin, maybe you only get one, the first one. So for this case, you have to apply permission access and user role equals permission access. That's the access that you are being asked for. If you have the permission access, then you are allowed to continue, but you have to filter if the user has this, because if you only validate user role equals permission access, you will ask, hey, do you have the access for that? But maybe the user is not a country state admin, is the country a contributor and a reader or a public, or you have a special situation there. So for this case, you are able to do this. They are a little cases for this. So this is going to this is something that you may consider for that. Additionally, we have the bitwise, the binary shift operators. The binary shift operators are related to I'm going just to let you this example for user permissions as Linux. And now I don't remember the command for comment everything. We have this, and now we have the other ones. I'm going to declare another number. I'm going to declare int number 03. This is equals to 1. Okay. Now this is the following 001. Now the binary shift operators. The binary shift operators are it's less, double less, or lesser than or greater than. How this works? Well, so I'm going to do write console write line apply to number 3. I'm going to apply first the lesser than. Yeah. This case is I'm going to move one position once. So it's going to be number 03 lesser than 1. Okay. Number 3. First, we have to validate the value of this. Number 3. And then we apply the lesser one twice. What does this operation do? Is we have this value for number 3, and the shift operator is going to move the numbers to the left. The lesser than is going to move to the left this amount of numbers, and greater than is going to move them to the right. So for this case, we have this number 3. If we move the numbers to the left, then the number is we need to move this one to 1, 2, and 3 positions. Okay, so for this case, we are going to have this one, and this number is 1, 2, 3, 4, 5, 6, 7, 8. This is the value of 8. Okay. .NET run. Let's see. Okay. I have some warnings, but right now I'm not going to consider them. I have one applied to number 3 once, and it was okay. I don't know what I say when I move this one. If I move just only once, it's going to um, we should go resume it. I this app. I don't that on Visual. Okay, yeah. So I have the one here. It's going to move once to the left, so the number is going to be 2. This is number 2. Uh, if we move this one 2 places to the left instead of 2, it's going to be 4. It's 1, 2, then 3, and then 4. Okay, this is the number 4. Execute the example, and yeah, instead of once, twice, this move your number. Okay, and now what happens to the left? Well, that was to the left. Now I'm going to apply it to the right. To the right is going to move the number, so I'm going to number equals I had another number, yeah, number 02. So number 02 console right line number 02 equals number 02, and then apply number 02 once. We have to change this once. Mhm. So we have the 02, and 02 is its value is 12, 1100, 1100. So if we move ones to the right, instead of having this, we're going to have this. That is 6. That number is 6. Uh-huh. Now let's see. .NET run. Let's see what happens. And we have number 02 is 12. Then we apply these ones and is 6. We have to consider that the number, if you move too much the numbers to the left, you are going to have um, a position where if you move too much to the left, instead of switching from uh, to the next number, to what will be the next number, I mean 1 million, from 1 million to 2 millions, 2 millions to 4 millions, instead of doing that, you are going to shift or to change the last bit of an integer, and that is going to change the sign of that number. So instead of having when you get around 2 billion, and then you shift once to the left, you are going to get less 2 billions. Okay, this is the case for this. I'm opening the calculator and I'm looking for the number one. um, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 30, 31. Okay, let's have copy. I have number 01 equals this one. This number is in binary 1, 0, 4. Okay, I need 8 of this. No, 1, 2, 3, 4, 5, 6, 7, 7. 1, 2, 3, 4, 5. 2, 3, 5. Then I have 7. 7 places of 4 zeros, and then 0, 1, 1. Okay, the next number, we move once to the left, we are going to have number 1. Number 1, please, Visual Studio Code, work on. Stop. Gosh. Yeah. Okay, I think I'm back. Number 1, then number 1, move once. Going to clear screen. .NET run. And here we have this. If you see, we have this number, the 1,073,000,000 741, etc. And then if we apply the shift to the left once, instead of having a positive number, we got a negative number. And this is the max amount of negative number. The almost max amount of negative numbers that we could have. Okay. And this is because we have, I'm going to change this to 25. Screen.net run. Okay. Because it's almost, you have this, and as you see, you have the last one as a 6. 46. It's changed because now the number originally was this, and then when we shift to the left, instead of getting this, you are moving ones to the left and the other one to the left, and we have this number. So we are almost at the end, at the edge of the negative numbers, and we are going to have an issue here. The same happens in if after this we apply to the right, because we are going to have less numbers. For example, for this case, if I apply to the right, a shift to the right 30 times, we are going to lose numbers. So what's going .NET run? As you see here in the example, if the same number you move to the right 30 positions, you are going to get only 1. And this is because you remove all of these numbers previously. You have 4, 8, 12, 16, 20, 24, 28, 29, time numbers. 4, 1, 5, 6, 7, 7 times 4, 28. Moving 30 is moving these positions, and you have and you have a 1 at the end. If you move it 31 times, you will get 0 because there is nothing else here. Let not run. See, number, you have 0, because for that case you have remove everything. Well, not remove, you have shift the whole information to that, and the information is being deleted, is lost. It's just like pushed, and there's nothing else that get that information. So it's an operation. Maybe this is a specific operation that you will use on a special time. It's not something that you use every time or every day, but you have the conditions to do this. And this is like a way to apply some conditions. Right now I don't have an example or a real life situation where you would use this, but the situation for this, you have to know that you have these operations, right? You have a shift, you have a bitwise binary operator, and maybe you are going to use it at a special moment. Right now, as I told you, I don't know which kind of special moment would you need for a shift operator, but it's useful to have it. Okay. Um, On C Sharp 9, additionally, I don't remember since which version, but in C Sharp 9, you have other two operators that are not assigned. They are they have a name, and you have the name of and size of operators. Those operators are for the following: the name of returns the short name of the variable type or member as a string. Um, this is when you need to understand what's the name of your variable that you have. It doesn't include the number of the namespace, the whole namespace. It only has the short name. And for the size of, it means the size of bytes of simple types. For this case, for example, mm, for this case, for example, I can set console name of size of console right line, and he will have name of number 01. Here you have number 01, right? Size of okay. So how do you use this? You have name of, and you have name of parenthesis, you have size of parenthesis. Huh? Hmm. I remember that size of was used this way. Size of, okay. One, let's warning. Number one is variable, but it's used by type. 147. Hmm. Number 01 doesn't have a size of, it's only be, okay, for this case I'm able to use this. You have to use types instead of variables for the size of, and this way you're going to be able to know the size that handles that type of variable. So you have here the name of number one is number one, the size of number one is 4. Well, and it's not number one, it's int. And this is the size of bytes, 8 bytes. Remember that you must remember that 1 byte equals of, sorry, screen. Bytes. Yeah, you have to remember that 1 byte equals 8-bit, so that 4 bytes equal 1 byte equals 8-bit and 4 bytes equal 32 bits, and number is 32-bit. What else we are going to have here? I think that for today this is going to be, yeah, for this case you will have the size. You also, for example, you are able to use this with the name of a variable, or that it's not useful because you already know the variable, but sometimes you will need the name of a class. So for example, string, you will need the name of a string. It's this is going to, okay, I'm just going to change this name of size of ham, name of string. You have to remember that string is a variable from, I don't know, system dot text dot text, for example, text builder, text builder, no, system dot text dot string builder. We have this. So if I pass this, the documentation says that name of only returns the simple name. It will be string builder. It's going to remove the namespace. .NET run. Yeah, you have this one. This is for the case when you need the exact name of the class that the class that you are using with that object. This for some cases that you need to use the specific name of the class. Sometimes you are able to just override it with another thing, but the name of is useful when you have a reference or you have to call an assembly that has that class and you have to look for that one. Basically this is it. Right now I'm pushing the this code. I'm pushing this code to the repo. um, going to add it stage variables, adding binary bitwise operator, binary shift operator, name of, and size of. Okay. Okay, I'm doing that. Now I'm going to merge that part to the repo. So you're going to have the repo updated with the latest version. Let's see, I just need to remove a folder. I'm going to five exercises. Five, 01. Operation variables. Remember that hit ignore. I remember that git ignore about bin. Yeah, it ignored. Okay, so bin and object, I'm going to remove them. Now commit. Using git ignore, commit and push. Okay. Yeah, okay. Now I'm going to do my net 5 exercises. .NET build. Just give me a second, I just need to validate that everything, yeah. .NET run, that everything is working on. Yes, yes sir. OBJ, the git ignore most. Operating variables. I don't understand what's going on. Commit. Using git ignore. Okay, now just a final validation. No, no. .NET build. .NET run. Yeah, now it's okay. This. Mhm. Now I prepare the pull request. Stage 1. I'm going to merge the stage 1 into uh, the main branch. Okay, okay. Now I'm going to complete it offline, but now you have this repo. You are able to use it, and you just could take a review, write your own exercises, look for the book that I told you since the beginning. I'm going to write it again. The name of the book that I'm using is from packedpub.com, and this is the name of the book that I'm using. So you have to take a look. .NET 6 is going to be announced for November. That the original consideration is to be announced on November, and then we are to be moving forward from .NET 5 to .NET 6, but we have to wait that to have the last release for that one. So this is all for today. I'll see you in the next week. I hope that you are enjoying these videos and you like these examples that I'm doing. If you want another topics, or if you want more advanced topics, I'm going to do some of them. I just need to take a review of .NET 5, because sometimes there are several things that you don't know about the language. You don't know about what the language is able to do with C Sharp 9, and for example .NET. With .NET 5 you are able to do machine learning, you are able to do mobile application development and web API, .NET ASP, .NET MVC, or console applications like the one that I'm doing right now. So I'm trying to cover all those topics and perform a basic sample with them, and this is it. So see you in the next week, and have a nice weekend. Bye bye.